You ever catch yourself doing something like completely on autopilot? Maybe it's that first sip of coffee you don't even really register taking.
Oh, yeah. Or the way you just kind of slump into the exact same spot on the couch every night.
Exactly. Those little automatic things, they're just scratching the surface of something way deeper.
Absolutely. What feel like these tiny everyday actions are actually, these incredibly powerful forces. They shape our lives in ways we often don't consciously realize at all.
Totally. And today we're diving into this really fascinating collection of sources that you, our listener, sent over. It's a great mix looking at habits from all sorts of angles.
Mm-hmm.
But we're not just talking about, like, how to kick bad habits, right?
Yeah.
We want to get underneath that. Understand the fundamental algorithms, and that's a great term. One of your sources use the algorithms driving so much of what we do day in, day out.
That's right. Your sources give us this really rich kind of interconnected picture. It's pulling insights from, how our brains actually work. That's the neuroscience bit and how we learn psychologically. And then there's the evolutionary biology side. Why are we even wired this way? And what I find really interesting is how we think about behavior in AI, in artificial intelligence.
Yeah, that AI perspective, seeing habits as these like learn automated processes, that feels really insightful.
It really is. It gives us a different lens.
And for you, our listener, who pulled together all this amazing info, our mission today is to really unpack the core stuff. We're shooting for those surprising insights, those kind of aha moments that make you see yourself and maybe the world around you just a little bit differently.
Yeah, our goal is to get right to the heart of how these habits actually function, the incredibly broad impact they have on us as individuals, definitely, but even on society as a whole.
Right.
We really want to understand what this means for, making personal changes, but also just for our basic understanding of why we do the things we do.
Okay, let's start unpacking this then. This idea of habits as learned behavioral algorithms, that really jumped out at me. Can you explain that a bit more? Especially, like, how does that compare to the usual psychological definition of a habit?
Sure. So think of it this way. From that AI angle, a habit is kind of like an efficient, automated little program running in the background of our behavior. It gets triggered by specific cues in our environment.
Right.
And it just spits out a predictable response based on what we've learned works, or at least what worked before. Now, psychologically, we define a habit by, well, first, it's automaticity. It happens with very little conscious thought. It's also cue dependent, meaning specific situations reliably kick it off. And this is a really key part. It's goal independent.
Goal independence. Okay, that's the bit that always kind of gets me. It means, like, you keep doing the thing even if you don't actively want the original outcome anymore. Is that right?
Exactly. Precisely. Yeah. You might have started, say, having that morning coffee because you genuinely needed it to wake up, feel alert.
Yeah, classic example.
Right. But eventually, just walking into the kitchen, that's the cue, can set off the whole coffee-making routine. Even on days when you're not particularly tired, the action just runs itself.
Huh.
One of your sources actually had a great, slightly unusual example, saying, Amen. After a prayer you only hear maybe once a year. It's still automatic, still cue-driven, even though it's super infrequent. That's different from, say, checking your email frequently, which you might still consciously decide to do each time.
Okay, that makes sense. So what's actually going on inside our heads, inside our brains, when these algorithms are running on autopilot?
Okay, so neurobiologically, we often talk about the habit loop. You've probably heard of this.
Vaguely, yeah. Cue, routine.
Cue, routine, reward. Exactly. The cue signals a potential reward. The routine is the actual behavior we do, and the reward reinforces that link between the cue and the routine. Now, a really key brain area in this whole loop is the basal ganglia. These are structures deep inside the brain. You can kind of think of the basal ganglia as the brain's main control center for, like, autopilot stuff, movements, routines, learned sequences. Within that, an area called the striatum is particularly crucial.
The striatum. So that's like ground zero for habits in the brain.
In a way, yeah. When we're first learning a new behavior, trying to reach a specific goal, one part of the striatum called the dorsomedial striatum, or DMS, think of that as the more decision-making part of this habit center. It's really active.
Right.
It's chatting a lot with the prefrontal cortex, the part of our brain involved in planning, making deliberate choices.
The thinking part.
Exactly, the thinking part. But here's the cool thing. As we repeat the behavior over and over and it becomes more automatic, more habitual, the brain activity actually shifts. It moves towards a different part of the striatum, the dorsolateral striatum, or DLS.
DLS.
And the DLS is more involved in like muscle memory, executing those automated sequences. The shift is also linked to something called chunking of neural activity. Yeah, the DLS starts firing in these distinct patterns that basically mark the beginning and the end of the whole habitual sequence, treating it as one single unit, one chunk. It's kind of like learning to type a familiar word. You don't think about the individual letters anymore, right? It's just one fluid motion.
Ah, okay. Like a little packaged routine.
Exactly. And meanwhile, that prefrontal cortex, which was so involved at the beginning, it kind of steps back, becomes less involved, which is efficient. It frees up our thinking brain to focus on other things.
Okay, this is where it gets really interesting for me. Dopamine has got to be involved here somewhere, right? It always is, with reward and learning.
Oh, absolutely crucial. Dopamine, that well-known neurotransmitter, plays a massive role in these brain circuits. But it's not just about feeling pleasure, which is a common misconception.
Right.
Dopamine neurons are really good at encoding something called reward prediction errors, or RPEs.
Reward prediction errors. Okay, what's that?
It's basically the difference between the reward we expected to get and the reward we actually got. It's like our brain has this little internal surprise-o-meter.
Huh, I like that.
Yeah, it helps us learn what's worth repeating.
Mm-hmm.
So if we do something and get a better than expected reward, boom, there's a positive RPE, a burst of dopamine. And that dopamine helps strengthen the connections, the synapses between the neurons that led to that successful outcome. It reinforces that cue routine link.
So it's like the brain giving a biological thumbs up, saying, yeah, do that again.
Exactly. That strengthening process relies on what's called dopamine-dependent plasticity, basically. The brain's ability to physically change its connections based on experience, guided by that dopamine signal.
Okay.
But here's what's really fascinating and kind of flips the script on dopamine. As a habit gets really ingrained, the dopamine release actually shifts. Initially, when you're learning, the dopamine spikes when you get the reward.
Right, makes sense.
But with enough repetition, the dopamine release starts happening earlier. It starts firing in anticipation of the reward, triggered just by the cue itself.
Whoa, really? Just the cue?
Just the cue. And this anticipatory dopamine surge is what scientists think drives the craving, that strong motivational urge, that wanting to perform the habitual routine as soon as we encounter the cue. The cue itself becomes powerfully motivating, separate from the actual reward.
Wow. So our brain learns not just the action, but learns to actually want to do it just from the trigger. That's a powerful mechanism. Okay, now, your sources also get into some computational frameworks, bringing in reinforcement learning from AI, this model-free versus model-based idea. Can you walk us through that? It sounds a bit technical.
Yeah, it can sound technical, but the core idea is actually pretty intuitive when you break it down.
Yeah.
Reinforcement learning, or RL, is basically a way to mathematically model how an agent, whether that's, a person, an animal, or even a robot, learns to make decisions in an environment to get the most rewards over time. And within RL, this distinction between model-free, MF, and model-based, MB learning turns out to be super relevant for understanding the difference between habits and more deliberate actions.
Okay, let's tackle model-free first. What's the gist there?
So model-free RL is basically learning through pure trial and error without building a sophisticated internal map or model of how the world works.
Right.
It doesn't really understand why doing X leads to Y. Instead, it directly learns the value of taking certain actions in particular situations or states.
Yeah.
It just keeps track. Historically, doing this action in this state has led to good things.
Like a stored memory of what works.
Exactly. It stores these expected long-term values and updates them based on those reward prediction errors we just talked about. If doing something in a certain situation consistently leads to a good outcome, the stored value of that action in that situation goes up. A common algorithm here is called temporal difference, or TD learning, where that RPE signal drives the updates. Now, because model-free systems rely entirely on these stored, cached values, they're really efficient and fast for making decisions in familiar situations. But, and this is key, they're very slow to adapt if the environment suddenly changes or if the rewards change. They kind of have to relearn the values from scratch through new experience.
Because they don't have that map to update.
Precisely. So this inflexibility, this reliance on learned stimulus-response associations, It makes model-free RL a really strong computational parallel for habitual behavior. And, connecting back to the brain, that dopamine RPE signal happening in the dorsolateral striatum, the DLS, that's thought to be the biological implementation of this kind of model-free learning.
Right, okay. That fits perfectly with that ingrained reaction.
Yeah.
You just do it based on past success without really thinking about the current goal or situation. So what about model-based learning then? That sounds like the opposite, more like conscious thinking.
Exactly. Model-based RL is much more sophisticated. It involves building an actual internal model or a cognitive map of the environment.
Like a mental map.
Yeah, exactly. This model understands how different states connect, how your actions cause transitions between states, and where rewards are likely to be found. With this internal map, the agent can actually simulate different possible sequences of actions internally. It can plan ahead.
Thinking things through.
Right. It evaluates the potential outcomes of different paths to reach a specific goal. This is obviously much more flexible and goal-directed. If the environment changes or your goal changes, the agent can just update its internal model and replan accordingly, often without needing direct experience in the new situation.
That sounds much smarter.
It is, but it comes at a cost. All that planning and simulation is much more computationally demanding. It takes more mental effort, more time, than just looking up a stored value, like in model-free. And in the brain, model-based control is linked to that deliberate decision-making we talked about, involving the prefrontal cortex and the more associative parts of the striatum, like the DMS.
So it's like having that mental map and actively choosing the best route versus just, automatically following a well-worn path. Okay, but how do we decide which system to use? Or do they kind of work together somehow?
Yeah, that's a really crucial question, and it's an active area of research. The thinking isn't so much that we purely use one or the other. It's more about a dynamic interplay, maybe even a kind of competition or collaboration between the two systems.
Ah, okay.
Early ideas were maybe a bit simpler, like a winner-take-all. Whichever system is more confident or predicts a higher value gets control. But more recent models suggest it's probably more integrated. Both systems might contribute to the final action choice, weighted by things like how uncertain each system is, or how reliable its predictions have been recently.
Interesting.
Some models talk about an ongoing arbitration process. Imagine the model-based system calculates the best action based on the current goal in its map, while the model-free system retrieves the value of the habitual action. These values are compared, maybe considering factors like the potential cost of computation for the model-based system.
Like a little internal negotiation.
Kind of. And there's this idea of an exploitation-exploration trade-off. How much should we stick with the known habitual option, exploit, versus trying something new that might be better, explore? Some models suggest that when we're more biased towards exploitation, just getting that familiar reward quickly that naturally favors the habitual model-free system, there might even be a sort of critical threshold where if the habit is strong enough, we just default to it.
That's fascinating. So there's this kind of subconscious cost-benefit analysis constantly running. You also mentioned other computational models, something about Q-intention links and Hebbian learning.
Yeah, besides the big MFMB framework, other models focus more specifically on how certain cues in our environment get directly wired to our intended actions through repeated pairing. This draws on that classic neuroscience idea of Hebbian learning, often summarized as neurons that fire together, wire together.
Right, heard that one. So these models basically show how the connection strength between the neural representation of a cue and the representation of a planned action gets stronger each time they occur close together in time, especially if there's a positive outcome. Over many repetitions, this strengthened connection can essentially become a direct pathway, a habitual link, where encountering the cue almost automatically triggers the action, bypassing more complex decision processes.
So it solidifies the link.
Exactly. And what's really compelling is how well all these different angles line up. The psychological definition of habit, that automaticity, cue dependence, goal independence, fits beautifully with the computational properties of model-free reinforcement learning, and also with these ideas about direct cue action links strengthened through Hebbian plasticity. It gives us really strong confidence that we're on the right track in understanding the mechanisms.
Okay, so we're getting a much clearer picture of how habits work, both in our brains and computationally. But let's zoom out again. Why? Why do we even form them in the first place? What's the big evolutionary advantage of running so much of our lives on this kind of autopilot?
Yeah, that's fundamental. From an evolutionary standpoint, the ability to form habits is seen as a really core adaptation, primarily driven by the need for cognitive efficiency.
Saving brain power.
Exactly. Our mental resources, things like attention, working memory, complex decision-making, they're limited. and they consume a surprising amount of energy. If we had to consciously think through every single little action, even the really routine ones like walking or tying our shoes, well, we'd be exhausted and incredibly slow.
Totally.
Habits allow us to automate our responses to recurring situations, the predictable parts of our lives. And this frees up those precious, limited cognitive resources so we can focus them on novel challenges, solve complex problems, spot unexpected dangers, or maybe recognize new opportunities in our environment.
Makes perfect sense.
So having this efficient way to handle the routine stuff would have given our ancestors a pretty significant survival and reproductive advantage. It's like our brains evolved this clever trick to offload the mundane tasks to a more automatic system, keeping the thinking brain fresh for when it's really needed. It's a powerful evolutionary hack, really.
Yeah, I can see that. Imagining having to consciously decide every single step of making coffee every morning sounds utterly draining. So the habit system is basically our brain's way of dealing with the boring but necessary stuff efficiently.
That's a great way to put it, yeah. Evolutionary psychology often talks about our minds being composed of many specialized mechanisms that evolved to solve specific, recurring problems faced by our ancestors in what they call the environment of evolutionary adaptedness, or EEA.
The hunter-gatherer world, basically.
Yes, it's often conceived that way, yeah.
Yeah.
The habit formation system can be seen as one of these core adaptations, or at least a fundamental part of how our learning systems function. The basic machinery learning through association, reinforcement that's likely universal, shaped by our shared evolutionary history. But the specific content of our habits, what we actually learn to do automatically, that's incredibly diverse. It's learned through our individual experiences within our specific environments, our cultures. So everyone has the capacity to form habits, but the habits we end up with vary hugely.
But you mentioned earlier this efficiency comes with a potential downside.
Yeah.
Right? That inflexibility piece.
Exactly. That's the crucial trade-off. The very things that make habits so efficient, their automaticity, the fact they become disconnected from our current goals, also make them resistant to change. They can become rigid.
Sticky.
Very sticky. And the problem is, the environment our habit system evolved in might be very different from the environment we live in now. When the world changes rapidly like it has in modern times, habits that might have been adaptive or at least harmless in the past can become maladaptive.
Like the classic example of craving sugar.
Perfect example. Our ingrained preference for calorie-dense foods, especially sweet and fatty ones, was super helpful when calories were scarce and hard to come by. But now, in our modern world of, easily accessible junk food, that same ingrained preference contributes massively to obesity, diabetes, and other health problems.
Yeah.
Or think about our tendency towards sedentary behavior. Conserving energy was probably a good strategy for much of human history, but now, combined with desk jobs and cars, it leads to inactivity and its associated health risks. It's a mismatch between our evolved predispositions and our current environment.
So it's like our brains are running on this really old software, originally designed for a completely different operating system, a different world.
That's a fantastic analogy, actually. Yeah. And this mismatch is why understanding habits is so important. We need to be aware of when our autopilot is leading us astray in the modern world.
Okay. Now let's dig a bit deeper into the biology behind these evolutionary pressures. We've talked brain regions, but what about neuroplasticity?
Yeah.
And our genes? How do they fit in?
Right. So those evolutionary pressures favoring habit formation didn't just happen in a vacuum. They physically shaped the brain structures we discussed, the basal ganglia, the dopamine pathways, their connections with the cortex. But the fundamental biological process that actually allows us to learn and store these habits is neuroplasticity.
The brain's ability to change itself.
Exactly. The brain's remarkable ability to rewire itself, to change its structure and function based on experience. Habit learning is experience-dependent plasticity, happening specifically within those corticobasal ganglia loops we talked about.
Okay.
Every time we repeat that sequence, cue, behavior, reward the synaptic connections, the junctions between the neurons involved in that specific pathway, they get stronger. And conversely, if a behavior stops leading to a reward, those connections can weaken. It's that neurons that fire together, wire together principle again, but critically modulated by dopamine.
Dopamine is like the conductor orchestrating the changes.
Yeah, it acts as that crucial reinforcement signal, telling the synapses in the striatum, okay, strengthen this connection, or weaken that one. It guides the physical encoding of the associations that ultimately lead to that automatic habit execution.
And what role do our genes play in all this? Are some of us just born more habitual than others or prone to specific habits?
That's a great question. While the basic capacity for habit formation seems to be universal, built into our human blueprint, there's definitely significant individual variation. We all know people who seem to form habits really easily, others who struggle, people who are prone to certain types of habits.
Yeah, definitely.
And behavioral genetics tries to understand how much of that variation is down to differences in our genes. They use methods like twin studies, comparing identical twins who share 100% of their genes with fraternal twins who share about 50%, and also adoption studies.
Yeah.
And these studies consistently show that many behavioral traits, including things related to personality, self-control, impulsivity, and even the likelihood of developing things like addiction, which is a kind of extreme habit, they all have a genetic component. The heritability estimate.
Heritability, that's the percentage of variation due to genes, right?
Exactly, within a specific population. For many complex behavioral traits, those estimates often land somewhere in the, say, 30 to 50% range. So genes clearly play a role, but they're not the whole story.
So it's not like there's a specific smoking habit gene or exercise habit gene. It's more subtle than that.
Precisely. It's highly unlikely there are specific genes for particular complex habits like smoking. It's much more probable that genetic variations influence the underlying neurobiological systems that are involved in habit formation in general.
Oh, okay.
So maybe variations affect how sensitive your dopamine system is to rewards, or how efficiently your synapses change strengths, that plasticity bit, or maybe your general level of impulsivity versus self-control, things like that.
Affecting the machinery itself.
Exactly. And it's really, really important to stress that genetic influences are probabilistic, not deterministic. They might create predispositions or tendencies, but they don't lock you into a specific fate. Heritability estimates apply to populations, not predicting any one individual.
Right. Environment matters too.
Hugely. And genes and environment interact in really complex ways. A genetic predisposition towards, say, addiction might only manifest if someone experiences significant stress or is exposed to substances early on. Conversely, a supportive environment might buffer against certain genetic risks. So think of genes as maybe influencing the parameters of that universal habit formation algorithm we talked about earlier.
Like the settings.
Yeah, like tweaking the settings. Maybe your personal learning rate is faster or slower. Maybe you're more or less sensitive to rewards. Maybe you have a stronger tendency to explore versus exploit. These genetic influences on the basic machinery could help explain why, even though we all can form habits, we see so much individual difference in our habitual tendencies.
That makes a lot of sense. It's like we all get the same basic software package, but genes might subtly adjust some of the default settings. Okay, so habits don't just magically appear fully formed, right? How do they actually develop across our lifespan? And are there noticeable differences between, say, kids and adults, or even between genders?
Right, habit development is definitely a lifelong process. It starts really early and continues to evolve, shaped by our maturing brains, our cognitive development, and just the sheer accumulation of life experiences.
So babies start forming habits.
In a sense, yes. Think about early childhood establishing those foundational routines around sleeping, eating, basic self-care, even simple social interactions like turn-taking. A lot of this is learned through imitation, observing parents and caregivers, and through the consistent patterns they establish. You could even see this as absorbing the habitus of our culture, as some sociologists call it, the deeply ingrained, often unspoken habits and expectations of our social environment.
Setting the stage.
Exactly. These early routines lay the groundwork for more complex habits later on. Then moving into adolescence and young adulthood, this is a really critical period. The prefrontal cortex is still maturing, giving us more capacity for goal-directed behavior and self-control, but it's also a time when we're forming lots of new habits related to education, work, relationships, health behaviors like diet and exercise.
Yeah, big habit-forming time.
Huge. We're navigating more complexity, making choices that can really set us on long-term habitual paths, for better or worse. The ability to automate behaviors becomes increasingly important just to manage the growing demands of life.
And what about later in life? Older adulthood.
Well, in older adulthood, habits that have been established over decades often become even more deeply entrenched, more automatic. This can provide a valuable sense of stability, predictability, and familiarity, which can be comforting.
But maybe harder to change.
That's the potential downside, yeah. It can make adapting to new circumstances or breaking long-standing patterns more challenging. Also, some age-related changes in cognitive functions, like maybe slightly slower processing speed or reduced working memory capacity for some individuals, might lead to a greater reliance on these energy-saving habitual responses. But again, there's huge variability in how people age cognitively.
Right.
Yeah.
Now, the gender question. That always seems like a tricky area. Are there real differences in how men and women form habits?
It is tricky, and the evidence is pretty complex and, frankly, often inconclusive when it comes to humans. There is some research, mostly in animal models, suggesting potential differences between males and females in things like how quickly habits are acquired or how flexible they are. And these are sometimes linked to the influence of sex hormones like estrogen or testosterone on those brain circuits we've been talking about.
Okay, but animals aren't people.
Exactly. Translating findings from rodents directly to humans is fraught with difficulty, especially for complex behaviors influenced so heavily by social factors. When researchers do look for gender differences in human habit formation, it's incredibly hard to untangle potential subtle biological influences from the massive pervasive effects of gendered socialization, cultural norms, different life experiences, and expectations that males and females encounter from birth onwards.
So observed differences might not be biological.
It's very possible. Any differences we might observe in the types of habits men and women tend to have as adults could simply reflect that same fundamental universal habit learning mechanism operating on different inputs, different environmental cues, different reinforcement histories, different social pressures and opportunities, rather than indicating a fundamental difference in the underlying algorithm itself based on sex or gender. We really need more nuanced research here that carefully considers the interplay of biology, identity, and sociocultural context.
Okay, so it sounds like habits are this really fundamental thread running through our lives, woven from our evolution, our biology, our development, and all our unique experiences. Now, let's zoom out again. How do these individual algorithms, these personal habits, scale up? How do they impact our lives day to day and even shape entire societies?
Right, the impact is just enormous, really, at both levels. At the individual level, as we've kind of touched on, habits profoundly influence pretty much every corner of our lives. Think about physical health, it's almost entirely driven by habits.
Diet, exercise.
Exactly. What we habitually eat, how much we move or don't move, our sleep patterns, whether we smoke or drink excessively, even whether we remember to take prescribed medication, these are huge drivers of long-term health outcomes and the risk of developing chronic diseases like heart disease, diabetes, cancer.
It's massive.
Massive. And it's similar for mental health and general well-being. Our habitual thought patterns, do we tend towards pessimism or optimism? Do we ruminate on negative things? Our typical ways of regulating emotions, do we lash out, withdraw, or use more constructive strategies? Our patterns of social interaction? These all become ingrained and significantly shape our mood, our stress levels, our life satisfaction.
Even things like studying or being organized.
Absolutely. Cognitive function, too. Our study habits, our organizational routines, where we tend to focus our attention, do we get easily distracted by notifications, how we manage our time, these are all habitual to a large extent. And the interplay between our automatic habit system and our more effortful goal-directed system is critical for effective functioning. Too much reliance on habits can make us inflexible, but an inability to form good habits can be equally problematic.
And relationships too, I guess.
Yeah, definitely. Our habitual ways of communicating with partners, family, friends, our tone of voice, whether we listen actively, the assumptions we make these patterns become deeply ingrained and have a huge impact on the quality and stability of our relationships. Even shared routines, like having dinner together, can become important relationship habits. It's almost sobering when you stop to think just how much of what we consider us is actually the product of these accumulated, often unconscious, habitual patterns.
Yeah, it is a bit unnerving, actually.
Yeah.
How much is really me choosing and how much is just the algorithm running? You even highlighted a specific, maybe slightly unusual example in the sources, the habit of swearing. Why pick that one out?
Swearing is a fantastic example because it perfectly illustrates that complex interplay between psychological function, social context, and automaticity. It's not just a bad habit for many people.
Right, it can serve purposes.
Exactly. Psychologically, habitual swearing can actually do things for us. It can be a way to vent frustration and regulate emotion. Surprisingly, it's been shown to sometimes increase pain tolerance.
Really?
Yeah. And in certain social groups, it can be a marker of informality, authenticity, even social bonding using shared taboo words can signal in-group status.
Like a secret handshake, almost.
Kind of, but, and this is the crucial point, its social acceptability and consequences are entirely dependent on the context. What's totally fine with your close friends might get you fired from your job or ostracized in a formal setting.
Yeah, obviously.
And because it can become so automatic, so cue-driven, maybe triggered by frustration or just being around certain people, it can be really hard to switch off, even when we consciously know it's inappropriate for the current situation. It perfectly highlights how the goodness or badness of a habit isn't inherent in the action itself, but emerges from its function and consequences in a particular context.
Right, that makes sense. It's not intrinsically good or bad, it just is, and the context defined its value. Okay, so how do these individual habits, like swearing or anything else, become collective? How do they scale up to shape whole cultures, or even the path of history?
That happens when individual habits become widely shared, learned, and transmitted within a group or society. They then form the bedrock of what we call cultural norms, customs, rituals, and traditions.
So culture is built on shared habits.
To a large extent, yes. You can think of culture as this complex web of shared beliefs, values, practices, and artifacts. And a huge part of that involves learned, shared behaviors, habitual ways of doing things, interacting, thinking. We mostly pick these up implicitly through observation and participation during enculturation and socialization, especially when we're young. We just absorb the typical patterns and routines of our society.
Without even realizing it.
Often, yeah. These shared habits create predictability, they smooth social interactions because we have shared expectations, and they contribute to our sense of identity as members of a particular group or culture. Now, it's useful here to maybe quickly distinguish between habits, routines, rituals, and traditions, as your sources did. While individual habits are primarily about that automatic, cue-driven efficiency we've discussed, things like routines, rituals, and traditions often have more conscious intention or symbolic meaning attached. A routine might just be a sequence of actions you do regularly, but it only becomes a true habit when it's deeply automatic and goal-independent. Rituals often involve very specific, rigid sequences of actions imbued with symbolic meaning, perhaps aimed at reducing anxiety or connecting with something larger than oneself. And traditions are long-standing customs or beliefs passed down through generations, often reinforcing group identity and values. They all involve repeated behaviors, but the level of automaticity, conscious meaning, and social function can differ.
So a shared habit, if it picks up meaning, might become a custom or tradition over time.
Exactly. It can evolve. And these collective habits, these shared ways of doing things, they have real historical weight. They can shape the trajectory of societies.
Can you give some examples from the sources?
Sure. Think about the history of hygiene habits. Practices around cleanliness, bathing, hand washing, waste disposal have varied enormously across cultures and time periods. Initially, they were often tied to religious beliefs about purity or miasma theories of disease.
Right. Bad air.
Exactly. Then came the scientific breakthroughs germ theory in the 19th century. This, combined with public health campaigns, sometimes called the gospel of cleanliness, and technological innovations like mass-produced soap and indoor plumbing, led to a dramatic shift in hygiene habits in many parts of the world.
With huge health impacts.
Massive impacts on reducing infectious diseases and increasing lifespans. But the adoption wasn't always immediate or uniform. It took time for these new habits to overcome older customs and for the infrastructure to be built. It shows how collective habits can change, but often slowly.
Okay, what else?
Another example is work habits. There's the famous, though often debated, thesis by Max Weber about the Protestant ethic, the idea that certain values emphasized in Protestantism, like diligence, thrift, and methodical work, fostered habits conducive to the development of capitalism.
The spirit of capitalism.
Right. Regardless of the specifics of that debate, it's clear that the Industrial Revolution profoundly reshaped work habits. Factory labor demanded a whole new kind of time discipline, synchronization, and repetitive work patterns that were very different from agricultural or artisanal work. People had to learn and internalize a completely new set of work habits.
Yeah, driven by the factory whistle.
Exactly. And a final example. Consumption habits. Think about the introduction of new goods like sugar, tea, coffee, tobacco into Europe starting a few centuries ago. Initially luxuries, they gradually became staples, deeply embedding themselves into daily routines and social rituals.
Coffee breaks, tea time.
Precisely. The way we consume coffee today isn't just about getting caffeine. It's wrapped up in cultural habits, social meanings, marketing, morning routines. These consumption patterns transformed economies, trade routes, and daily life. These historical examples really drive home how collective habits aren't trivial. They create social structures, they have inertia, and they play a huge role in how societies develop. Sometimes for the better, like public health, sometimes creating challenges, like unsustainable consumption or health inequalities.
It's incredible, really, that something starting as one person's automatic action when multiplied and passed down, can literally alter the course of history.
Wow. Okay, this naturally leads into some pretty deep philosophical territory, doesn't it? If so much of our behavior is automatic, what does that mean for concepts like free will or personal responsibility? It absolutely does. The automatic, often unconscious nature of habits poses a real challenge to our intuitive sense of free will and moment-to-moment control. If a large chunk of what I do just sort of happens in response to a cue, without me consciously deciding to do it right then and there, well, where does my agency fit in?
Yeah, it feels a bit like being a passenger sometimes.
Right. Psychological research confirms that feeling many habitual actions are initiated and executed with minimal conscious awareness, feeling effortless, maybe even involuntary. This kind of clashes with the folk psychology idea that we are the deliberate authors of all our actions.
So are we off the hook responsibility-wise?
Well, probably not entirely. While the execution of a well-established habit might be largely automatic, the neuroscience and psychology also suggest we usually do have influence over the formation and maintenance of our habits over the longer term. We make conscious choices, maybe implicitly or explicitly, about which behaviors to repeat, which environments to put ourselves in, which goals to pursue.
So the responsibility shifts time frame.
That's a really good way to think about it. Perhaps responsibility lies less in scrutinizing every single automatic twitch, and more in taking ownership of the process of shaping our overall character, our set of habitual tendencies over time. Am I consciously trying to cultivate good habits? Am I making efforts to identify and change detrimental ones?
That connects to older ideas like virtue ethics, doesn't it?
Ah,
Aristotle and all that.
exactly. Virtue ethics emphasizes the importance of practice and habituation in developing moral character. Virtues are seen as stable dispositions to act and feel in certain ways, essentially well-cultivated good habits, while vices are ingrained bad habits. Becoming a good person isn't just about knowing what's right. It's about consistently practicing right action until it becomes second nature, habitual.
So we're responsible for the habits we build, which then shape who we are.
That's a compelling perspective. And when we evaluate habits as good or bad, it's rarely black and white, as we saw with swearing. It's highly context dependent. Is the habit aligned with my personal goals and values? Does it promote my well-being and the well-being of others? What are its consequences in different situations? Societal norms also play a huge role. Think about changing views on smoking or different cultural standards of cleanliness or punctuality.
Right. And ethically, when we think about interventions to change habits, whether personal or public health campaigns, we need to consider things like autonomy, right? Avoiding manipulation, ensuring equity.
Absolutely. Those are really important ethical considerations in designing and implementing habit change strategies.
This all feels incredibly interconnected. How do our habits actually interact with our emotions, our beliefs, and just our general mental state day to day?
It's definitely a dynamic interplay, a constant two-way street, really. Let's break it down.
Yeah.
Emotions and habits first. Emotions can be powerful. Triggers for habits. Feeling stressed might trigger nail biting or reaching for comfort food. Feeling bored might trigger scrolling social media. And emotions can also be consequences or reinforcers. The temporary relief from stress after eating chocolate reinforces that habit loop. Conversely, habits can also modulate our emotions. Going for a run, a habit for some, can reliably lift mood. Habitually practicing mindfulness might reduce overall anxiety levels.
How they feed into each other.
Definitely. Then there's beliefs and habits.
Yeah.
Our beliefs about ourselves are crucial. Do I believe I'm capable of forming a new habit? That's self-efficacy. If you don't believe you can do it, you probably won't even try seriously.
It makes sense.
Our beliefs about the outcomes of a habit also matter. If I believe exercising will make me feel better, I'm more likely to stick with it. Interestingly, habits can also shape our beliefs, not just the other way around. This relates to cognitive dissonance.
Oh, right. When your actions and beliefs don't match up.
Exactly. If I have a habit, say, of eating unhealthy food, but I believe I should eat healthily, that creates dissonance, an uncomfortable feeling. To resolve it, I might either change the habit, which is hard, or sometimes I might subconsciously change my belief. Maybe I start thinking, oh, it's not that unhealthy, or I deserve a treat. I rationalize the behavior by tweaking my belief system to align with my actions.
Wow, that's sneaky.
It is. And finally, our general cognitive state, how tired, stressed, or mentally overloaded we are, significantly impacts which system takes over, the habitual or the goal-directed one.
We fall back on habits when we're tired.
Precisely. When cognitive resources are low, maybe you're fatigued, stressed, multitasking, or even under the influence of alcohol, we tend to rely much more heavily on our automatic energy-saving habits. They just require less mental effort. This is efficient, but it also explains why we often slip back into unwanted habits when our willpower is depleted or we're under pressure.
So being aware of that is important.
Hugely. Practices like mindfulness can be really helpful here. By bringing more awareness to our internal states and automatic tendencies, we can sometimes create a crucial pause, a space where we can notice the urge to act habitually and maybe choose a different response. So overall, habits are deeply interwoven with our emotional regulation, our belief systems, and our moment-to-moment cognitive functioning. They create these self-perpetuating cycles for good or ill.
Okay, understanding all these inner workings feels like the key to actually getting a handle on our habits. So let's get practical. How do we become more the master of this algorithm rather than its servant? What are some really effective evidence-based ways to break the habits we don't want and build the ones we do?
Right. Becoming more intentional about our habits really boils down to understanding that learning process we've been discussing and then strategically intervening in its key components. Remember the core elements: initiation, deciding to start; repetition in a consistent context, linking behavior to a cue; getting some form of reinforcement or reward, that dopamine hit, satisfaction, the time it takes, it's not instant; maybe learning from others, social influence, and the whole environmental setup.
Okay.
So whether you're trying to ditch an old habit or install a new one, the most effective strategies are those that deliberately target one or more of these elements.
Got it. Let's start with the hard part. For many people, breaking those unwanted habits. What actually works based on the science?
One of the most powerful strategies is simply cue disruption or cue avoidance. If you can change your environment to remove or minimize exposure to the triggers that set off the unwanted habit, you make it much less likely to occur.
Out of sight, out of mind, kind of.
Pretty much. If the cue isn't there, the automatic routine doesn't get activated. Now, if you can't completely avoid the cue, the next best thing is often response substitution.
Swapping it out.
Exactly. Consciously plan a different, preferably more desirable or at least neutral behavior to perform instead of the unwanted habit whenever you encounter that trigger. Have a pre-planned alternative ready to go.
Like chewing gum instead of smoking when stressed.
Perfect example. Another tactic is to increase friction. Deliberately make the unwanted habit harder, more inconvenient, or less pleasant to perform. Put the cookies on a high shelf, delete the tempting app from your phone's home screen, add a financial penalty for slipping up.
Make it annoying to do.
Right. Conscious monitoring and inhibition techniques, like those used in cognitive behavioral therapy, CBT, can also be very helpful. This involves actively paying attention, noticing the urge when it arises, and consciously choosing to inhibit the habitual response. It takes effort, but it brings the automatic process into conscious control. And finally, really strengthening your commitment to competing, positive goals can give you more motivation to override the unwanted habit when the urge strikes. Remind yourself why you want to change.
Okay, those all sound logical, targeting the cue or the response. Now, what about the flip side, building new positive habits? What are the keys to making those stick?
Building good habits is really about making that learning process as smooth, easy, and rewarding as possible. First, be really clear about the goal, but break it down into a simple, specific, small action you can do consistently.
Start small.
Definitely. Then, create what psychologists call implementation intentions. These are concrete if-then plans that explicitly link your desired action to a specific situational cue. So not just I'll exercise more, but if it's 7 a.m. on a weekday, then I will put on my running shoes and go out for 15 minutes.
Making it super specific.
Exactly. Choose a cue that's already stable and reliable in your daily routine. Maximize repetition and consistency, especially in the early days. Try to perform the action every single time the cue occurs. Tracking your progress can help here. Critically, engineer some kind of immediate reward or satisfaction for doing the new behavior. Our brains are wired for immediate gratification. Even something small, like ticking a box, feeling a sense of accomplishment, or pairing the new habit with something you enjoy, can help reinforce the loop.
Like listening to a favorite podcast only while exercising.
Perfect. That's habit stacking or temptation bundling. Also, reduce friction. Make the desired habit as easy and convenient to perform as possible. Lay out your workout clothes the night before. Prepare healthy snacks in advance. Remove obstacles.
Make it the path of least resistance.
Exactly.
Yeah.
And finally, don't underestimate social support. Tell people your goals, find an accountability partner, join a group. Leveraging social connections can provide huge motivation and encouragement.
It sounds like a lot of it is about consciously designing the process rather than just relying on willpower. You mentioned earlier that breaking habits often feels harder than building new ones. Why is that, fundamentally?
Yeah, that perceived difference in difficulty really comes down to the underlying neural processes. Forming a new habit involves gradually strengthening those synaptic connections through reinforcement learning, making the pathway more efficient and automatic over time. It's like paving a new road.
Okay.
Breaking an existing habit, especially a strong one, requires actively fighting against that already well-paved, efficient, automatic pathway. You have to inhibit the established response, which often means engaging the more effortful, energy-intensive, goal-directed system, that prefrontal cortex again, to override the autopilot.
You're fighting against momentum.
Exactly. It's like trying to steer a car that really wants to stay in a deep rut. You're essentially trying to weaken those strong existing neural connections, often while simultaneously trying to build connections for a new alternative behavior. It requires sustained effort and often feels like an uphill battle against your own brain's tendency towards efficiency.
That makes so much sense. It really feels like understanding this whole algorithm, the cues, routines, rewards, the brain systems involved, gives us a much clearer, more practical roadmap for both understanding why we do what we do and for actually making meaningful changes.
Precisely. It moves habit change away from just vague notions of willpower and towards concrete strategies based on how learning and the brain actually work. By understanding those core components, we can be much more targeted and effective in our efforts, whether we're trying to ditch habits that hold us back or build ones that help us thrive. And remembering that individual variation piece, how long it takes, what rewards work best, reminds us to be patient with ourselves and persistent in the process.
So just to kind of wrap this all up, the big takeaway seems to be that habits are these incredibly powerful, learned algorithms running in the background, shaping so much of our lives, for better or for worse. They give us this amazing efficiency, but they also carry this potential for rigidity, for getting stuck in patterns that maybe don't serve us anymore.
Exactly right. It's that fundamental trade-off, the blend of efficiency and potential inflexibility, that makes understanding habits so crucial for understanding ourselves.
So for you, our listener, who sent in these really fantastic, thought-provoking sources that got us talking about all this, maybe here's a final thought to chew on. What's one small, maybe seemingly insignificant habit in your own life, something you do totally on autopilot that, when you really stop and think about it through this lens, might actually be having a surprisingly large impact, positive or negative?
Yeah, and just ponder. What might happen if you consciously decided to make just a tiny tweak to that specific algorithm? What might change down the line?
It's definitely worth reflecting on, maybe even revisiting some of the ideas or the sources that particularly struck a chord during our deep dive today.
Absolutely.
Well, thanks so much for taking this deep dive with us. It's always incredibly fascinating to explore these really fundamental aspects of what makes us human, isn't it?
It really is. Always learn something new.
This is DigitView.